full presentation notes. So I've had the pleasure of knowing Hassan for a couple of years now. It's been great watching the progress, and I'm really excited to see the demo of Bella Spree, which I have not yet seen, I think. And but first, we have to do a Groq demo. So sorry to be between you and the Bella Spree demo, but hopefully we'll find this interesting as well. For me, 2023, it's October, still plenty of the year left in a way, right? But for me, 2023 will always be the year of large language models. And I think that's true for a lot of us. How many people have tried ChatGPT? Almost everybody. This makes it easy for me. How many people have heard of Llama? Yeah, okay. This is a good crowd. So today I'm here. That's me. Please come and say hi after the talk, and just use this as a way to think of things to talk about. My partner, Amr. Oh, there's Amr. Okay, say hi to Amr as well. Unfortunately, Adam could not make it and sends his regrets. So 2023, the year of large language models. I mean, it really began a little bit last year, but caught on over kind of Christmas break. Everybody came back and started talking about ChatGPT, and we started talking about it, started using it. And then some things happened out there, as it does. You know, Meta got a little bit, I don't know, riled up about the progress. And, you know, they released, in February, they released Llama under a fairly open license. That license has since improved, and they've all gone on to release Llama 2 and other variations, very useful models, very capable models. And these models are things that people want to run because they can get their hands on them. They can deploy them inside their business. They can tune it. They can do all the kinds of things you would want to do with ChatGPT, that have a lot more control and maybe save money. So in February, we got our hands on Llama. We compiled it quickly. I won't bore you with a lot of technical details here, but you know that's not easy to do on any particular AI accelerator platform. Oh yes, we are an AI accelerator platform, kind of a hardware company turning into a solutions company overnight, I would say. Other folks have waded in, and so this is the headlines we've been seeing. We announced that we were able to compile and run it. That was an achievement all by itself. We did that very quickly early in the year. And since then, we've been on a march to improve performance. For us, these are the largest models we've had our hands on, and we're assembling the largest systems we've ever built to run these models. You'll see the results of that in a second, and I'll come back to if you're interested. How we were able to achieve these results. We announced at the end of July that we had Llama running at 100 tokens a second, and we've been on a march to increase our speed to approaching 300. We'll see what the demo is today, but we're getting close, and we will achieve that soon. And we're not stopping. So we have a lead over NVIDIA in terms of speed. So we have the lowest latency version of Llama available. Estimates may vary on what you can get on NVIDIA. We're conservative, and I have not personally seen it running over 20 tokens a second on NVIDIA. So some programmers may be able to achieve better, and who knows what tricks NVIDIA's got. We have a large lead of over 10 times the speed. And that is not just attracting interest in our platform to run existing workloads. It's literally changing how people think of what you can do with LLMs. So enough of that. I'd rather see a demo too. So we have what you're seeing here is, we call it Groq Chat. It's, I'm going to put the type right now. Hang on. So I'm trying why is the sky blue? Make it very technical. You can ask any kind of questions to this thing. All right, so I'm going to hit enter now. And so that's running at 289 tokens a second. So if you have used ChatGPT, you see chunk. This answer comes out in just about a second. We can also change the persona. There's all kinds of things you can do. If you're into the world of prompt engineering, that that stuff can make it different. We can summarize the result. If you have a nice UX in front of it, you can also get that fast. We can go back to expanding it. So imagine writing your self-review at the end of the year. Just dump it all in the computer and have it happen in 2 seconds. That'd be a nice experience. That's the kind of thing that's happening. Anybody have a query they'd like to run? Yeah. Oh, no. Okay, sorry, I didn't put it. Go ahead. ChatGPT is not something that we have available to us.
NVIDIA, you were showing a slide and that's
yeah.
profit or bond.
Okay.
They have a bond with NVIDIA.
Well, I think you should think of us as a competitor to NVIDIA. I'm not sure they worry about us that much. We're still a small company, but they'll be worrying more. So we have an AI hardware. Well, how do we do this? Let's get back to the. Go ahead. Question.
What is the cost of NVIDIA? What is it?
The cost structure. Yeah, we're not talking about that today. What I will say is we're fast, and if you have a low latency, large scale use case, we should talk, and you'll be happy with the outcome. So we're not talking about pricing, but if you want to button the whole armor, go for it. Go ahead, stand up.
Half the power, same cost, and 30x inference.
Yeah. So I didn't say much about Groq or what we do or what we did and all that sort of stuff. So let me just say 2 words about that, and then we'll get off the stage.
For TCO, definitely we're way ahead. So it comes down to TCO. Total profitability.
How did we do it? We did it with the language processing unit. It's an AI accelerator. Sometimes we fondly call it Groq chip. Groq chip, this is about the size of a GPU, radically different design. I'm not going to spend time on that, but I urge you to go to our YouTube channel or our website if you want to learn more about it. It's a fascinating story about how it came about. The language processing unit sits on a card, a PCI card. You put 8 of those in a node. We call it a Groq node. If you put 8 of those together, we put in a rack. We call that a Groq rack. And so this particular model is actually running on a large-scale system. It's running on about 8 racks right now. For the full throughput, we'd probably have it on a 10-rack system. It would be 640 chips. So super fast. So we're spreading this model across a lot of chips. The way our chips work is they act in unison. They really act like a single core due to our very unique deterministic design principles. Again, I won't spend time on that. But that enables scaling beyond what GPUs can do. So this model, large model, spread across many chips, actually fits in SRAM. And that's where we're getting the performance. And then, of course, it's a large-scale system, so we need to keep it busy. So we're adding the capability to support many, many users at the same time. That is the thumbnail sketch. There's obviously a lot of details behind that in complexity. Did I plant that question? That is a fantastic question. So what we do is we have a different strategy. We're a small company, about 200 people. We have been working on a very different software strategy. I think a superior software strategy. We have a compiler. So we get the PyTorch code. We take out all the CUDA that might have been placed there for inference or other reasons. We take our PyTorch code. We export it through something called Onyx, an open source tool. And that is the entry point. What? It's called Onyx. So that is a format, kind of a standard, but not the greatest standard. But it is a way to get models running on the edge. We have repurposed that tool as an entry point for our compiler. So we take Onyx as input, export it. You can think of it as taking PyTorch, and then we can compile that. And then we do some things to make it fit on a large system. And that's how we do it. And so all of the optimizations that make this model run fast are in the compiler. There's no hand tuning, handwritten kernels. There's a lot of, if you're trying to get things running fast on a GPU-based system, there can be a lot of hand tuning just to make the inference run fast. We run it all through our compiler, so our compiler gets smarter and smarter. So when the next model shows up, many of the same strategies apply to that model. So this is a compiling, it's a compiled model.
That SDK we offer, we download it, user-based. You don't need to give us your model. You can actually run the model. Yes. Register report, sign the NDA.
Yeah. So I want to
work on TPU. What kind of TP?
No, will not work on a TPU. Yeah, I like the question. No, I think that the SDK works extremely well for smaller models running on smaller systems. The challenge this year has been taking the largest models, putting them on the largest system. So current SDK wouldn't compile Llama, but we're on the road to that.
So you're comparing a Llama 70 billion model with a ChatGPT 4, which is over a trillion.
Oh, yeah.
But that's why it's faster and that's why it's cheaper, isn't it?
Well, I'm comparing Llama on our hardware to Llama on other hardware.
Ah, okay.
And I'm saying that the model's capabilities are similar to, I'm not going to say they're identical or superior to that. You may find that the task you want to accomplish needs ChatGPT. Okay, fine. There's a lot of tasks that we'll be very happy with Llama 70 billion.
You on inference and
This is this demo that you saw is running in a data center.
we're talking about power.
This model's too large for that.
Data center,
So we have customers that are extremely excited about the potential for low latency, and really that's the reason to call us. And some of them want on-prem, and it's complicated, and some of them would rather just have an API. So essentially the world is, we have a spectrum of business opportunities we're trying to sort through right now.
if your hardware, if you need it on-prem, or you will release the API probably.
Are you a provider or
Yeah, what a great question. Can we get these guys to come to the office?
Yeah.
Okay,
understand what's the story?
the story is you're looking at a hardware company
Okay.
that is turning into a solutions provider in front of your eyes. Yeah, and I come from the software world, so I'm happy about it. But, yeah.
Quick question. So Llama is 70 billion. What is what is Groq? This version of Groq or you?
No, it will work. We'll just compile it. We might need more hardware. So, for example, we've had 7 billion running on 1 rack, 13 billion running on 2.5 racks, and that's where it hits maximum speed. And then this one's running on 8 racks, so probably go to 10 racks to have the highest throughput.
If you have access to cache, would it run on your hardware?
I would say yes, but that's a qualified yes. We'd have to have our engineers take a look at it. They've probably got a lot of things happening in there that some of which we've seen before, and others maybe it's, I don't know how much fancy stuff is in ChatGPT. But probably the family of models, transformers, run extremely well on our hardware in general. It's really, if you look at how the calculation is done, it's this giant cascade of matrix multiplications. I didn't spend time describing our hardware, but that is the secret sauce of our hardware. It is outstanding.
Wrap up.
We're taking a lot from the model.
Yeah.
Running into the compiler, right, typing the compiler gets better, allows us to release that. The goal is also to take fine-tuned versions of those foundational models, drive them through the compiler, you as a user, right, and then eventually your custom model.
So,
Yes, we have a site you can actually go to, the Hugging Face Groq. Basically, you'll see how we run models, scour the Hugging Face and run the models through the tool, and you'll see the performance, the number of chips it takes. Right, so it is. We're open on it, right? We're not trying to hide it.